Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome Steven Wachs. Steven has 30 years of wide-ranging industry experience in both technical and management positions. He's worked as a statistician at Ford Motor Company, where he has extensive experience in the development of statistical models, reliability analysis, design experimentation, and statistical process control. Steve is currently a principal statistician at Integral Concepts Incorporated, where he assists manufacturers in the application of statistical methods to reduce variation and improve quality and productivity. He also possesses expertise in the application of reliability methods to achieve robust and reliable products, as well as estimate and reduce warranty. In addition to providing consulting services, Steve leads training workshops in a variety of statistical methods. Steve has an MA in Applied Statistics from the University of Michigan and an MBA from the Katz Graduate School of Business at the University of Pittsburgh. He received his Six Sigma Black Belt while working at Ford Motor Company. Steve Wachs, welcome and thanks for joining us today.
Well, thank you, Tim. It's a pleasure to be here with you.
Steve, I'm sure you've heard people say that there's rarely enough time to prevent a quality problem, but somehow there's always enough time to fix a problem after it's occurred. Why is it that so many organizations are unwilling or maybe unable to invest in defect prevention activities, and how can they be convinced to do more prevention?
Well, I wish I knew the full answer to this question. There's probably several reasons, I think, why not enough effort spent on prevention. I'll offer a few ideas that I have. It might come down to what is actually measurable or quantifiable. In other words, how do we quantify the prevention of a major issue that occurs, and especially when success means that those issues will never actually occur. I think
Good
back.
point.
I think back to just an example of that when I was working at a Six Sigma Black Belt at a prior company, and we were told that for us to work on any initiative or project, we had to upfront show that absolutely positively we could quantify the savings, and they'd be, say, at least $250,000 per year. So it was certainly plausible to work on fixing an existing problem that was causing a company to bleed cash, but that would never allow us to actually work on preventing some future big problem. So I think sometimes it just comes...
I'm sorry, Steve, that's because you couldn't point to a specific cost savings that could be realized?
Yeah, exactly. I mean, we all know that some of the prevention activities are going to pay off, but because the action or the issue that was never happened is it's unknown how big or whether it was going to turn into a multi-million-dollar lawsuit or a safety issue or just horrible inefficiency within a plant. It's hard to know what issues have been prevented, and certainly we have prevented many issues, but I think we can do a lot more to prevent many more issues. And so I think just that in a company, we all have objectives and we're rewarded based on actions. Sometimes it's harder to quantify actions that are more preventative in nature than versus reactionary, where we can see a direct benefit.
Yeah, I think we're also talking about something. We're talking about something that has a possibility of happening, but not a certainty of happening, right?
Yeah, exactly. I have come across in my career a few examples where this was sort of just not an issue. One of my favorite clients that we worked with some years ago, really to help transform their operations. This was a company that was working in a highly competitive area and a highly commoditized business was highly commoditized. So, efficiency was everything to remaining competitive. And it was pretty rare that the director who hired us I think she actually had a degree in statistics. So I think she got it. But her thing with her staff was she had them focused on simply reducing variation in key process characteristics. It was not about, quantify how much you're going to save on this project or that project. Her measurable was, what is the standard deviation today, and what is the standard deviation when you're done with this improvement project.
Right.
Now, obviously, we have to know. There's some upfront work to make sure we're reducing variation on the important variables, but she trusted that by reducing variation on key characteristics, that was going to lead to a lot of savings with regard to, scrap, efficiency, potentially warranty issues, and avoid a lot of problems. And it actually did. When you tracked what happened over a period of years, it was a dramatic impact.
Steve, that kind of reminds me of Taguchi and utility costs.
Right, sure. The Taguchi loss function, and basically says that cost is inversely proportional to variability, and I think that's one of the great ideas that comes out of Taguchi. I just can't. You mentioned in the question that there's always money for dealing with big issues, and maybe not so much for prevention, and that's been my experience. While our firm does a lot of consulting and training in the area of applying statistical methods and process optimization, a big side of our business, and I'd say it's actually growing, is being expert witnesses for product liability cases. And, we testify as to causes of failure and how it really comes down to, could this problem have been prevented with better manufacturing practices or better reliability testing and that kind of thing. But when those cases come up, companies, they open up their checkbook and pay for lawyers and experts, and they don't question what it's costing at that point, because they're just trying to defend their reputation and a huge potential dollar amount that they could be liable for. So
right.
There's no question that we sort of have to change the mindset from waiting for bad things to happen and dealing with those to more of prevention. And I can think of just a couple ways that we could maybe do a better job of that. I think it's back to the manager, the client that I really liked working for. I think more leadership has to have that vision of the importance of understanding our processes, reducing variation. It's a leadership issue. And I think also where we are deploying some preventative methods, for example, failure mode and effects analysis, which is a very common approach for trying to anticipate failures, both on a design and a processing.
Sure.
Those are wonderful methods. I think, though, that we often aren't taking advantage of maybe some more quantitative approaches like design of experiments and things, and more sufficient reliability testing, so that we have a greater assurance that we're doing everything we can to understand our processes and products, and uncover potential issues that could arise both, with a design and in the manufacturing of that design.
Steve, it seems like there's a lot of confusion about the purpose and the value of statistical process control. What are some of the common misunderstandings or maybe incorrect applications of SPC that you've seen in your work?
Yeah, well, gee, that probably something we could talk about for the whole time here today, but I'll pick on a few, I guess. I think first it starts with, do enough people really understand the purpose of SPC and what it's all about? And, I never fail to come across people that think SPC and control charting is about ensuring that we're meeting specification, and that really it's a tool to help us inspect product, which is kind of tells me that people are kind of missing the whole boat here. The whole purpose of SPC is to monitor important inputs to our process characteristics, to detect changes that may be harmful. And these could be, mean shifts in the process. They could be changes in the amount of variability that we have in the process. And that's really what it is. It's a way to detect a change so that we can react and understand the causes of these changes. I think another one would be understanding how this stability question relates to capability.
Right.
And again, it's I think there's a link between that. They're separate tasks. One is to achieve control or stability of a process, but then, of course, we must also meet specification,
Right.
which is what capability is all about. But the link is that, sometimes I see people just trying to focus on capability, and they have no idea whether their process is stable or not, which is kind of putting the cart before the horse. I mean, I see a lot of companies asking their suppliers to qualify a product simply by sending in, say, a CPK statistic. But they're not bothered that they're not asking for evidence of stability first. So, just because a process happens to be capable at a point in time when their supplier collects the data, does not mean that things are going to remain stable and that the capability will remain that good, as the product continues to be manufactured and sources of variation creep into the system. So this idea of capability without assuring ourselves that we're stable is kind of nonsense.
Yeah, you're absolutely right. A lot of times we have customers leaning on us to improve quality and reduce defects. But if you don't start with process control, you have no way of sustaining those gains.
Yeah, exactly. And and then there are many aspects to getting process control right. It's certainly not a complicated tool to use, but there are some important aspects to it. There are lots of different charts, right? The traditional charts were, invented in the 1920s, and they still work for many applications. Yet more and more, we're running across more complex manufacturing processes. I'll give you an example, like injection molding, where we have a 4 or 8 cavity mold. That kind of process usually requires something beyond the traditional individual moving range or X-bar R charts or X-bar S charts, because we often have sources of variation that are within cavity and between cavity. And so, there's a charting system which looks at 3 charts that allows you to manage these kinds of multi-stream processes. And it's pretty rare when we're in a client and we don't see applications for these, but honestly, I don't see a lot of people that familiar with them. And even just knowing when we should be charting averages versus individuals, it comes down to having to, the understanding. The purpose of SPC, as I said, is to detect changes. So a natural question would be, okay, well, how much of a process change from a practical perspective do I really want to detect? I don't want to be overreacting to tiny shifts that aren't going to affect my product performance or affect my customer.
Right.
But on the other hand, I certainly don't want to miss important shifts. And so understanding that first, and then, the smaller the shift we need to detect, that means the more data we generally need. And so we would be using an X-bar chart with an appropriate sample size. These are just basic questions that I think need to be answered. And unfortunately, I see too much of, let's just throw a chart on the wall, and we're not going to necessarily worry about the sample size or which chart is the best one to use, or so we kind of lose the benefits or don't achieve the benefits that we could get from a lot of these charting techniques.
It sounds more like window dressing.
Unfortunately, yeah. That's often just all it's needed to pass an audit, but that's not really why we should be implementing these methods. It's to really make a big difference in the quality and reliability of our products.
Steve, it seems like customers have a role to play here. Customers should be asking for some kind of evidence of process control from their suppliers.
That's a no-brainer, obviously. If you think about, pick, today where the most companies are so reliant on their suppliers. I live in Detroit, so I'm thinking of automotive, even though a lot of my business is not automotive. But what is an OEM going to do with SPC in their own assembly plant? Not much, right? All the manufacturing variability is coming from the supply base, and if those suppliers aren't capable and in control, right, they're going to be dealing with a lot of variation in assembly. They're going to be dealing with lots of variation in their products, and their customers are going to experience uneven performance, and that's why we have annual warranty bills that could be like 1/3 to 50% of our profits in our industry. It's a lot of money is being left on the table.
Very good point. Steve, I think it's important for people to understand that you don't have to be a Six Sigma black belt to manage or support a quality improvement effort. and also that it's not the job of the quality organization to improve quality. It's really everybody's job. Could you describe some of the basic tools and analytical processes that anyone can use?
Yeah. So, I mean, well, first of all, I agree that we don't need to. The black belt's not required, but I do believe that personnel that are involved in product development and manufacturing, they do need a basic working understanding of some important tools and methods,
Sure.
with hopefully some support from more experienced personnel, whether that's a black belt or an industrial statistician. I mean, my personal feeling is that it can be unfair to expect a black belt who's been maybe through 4 weeks of training to be an expert in a lot of these
Right.
tools. So, I mean, but that said, yeah, I mean, we've talked a little bit about SPC already, but certainly there's other tools that are critical. I mean, this all starts with data, right? And before we even use data for any kind of decision with regard to, is my process stable or capable, or comparing groups or what have you, we need to, of course, make sure that we have an adequate measurement system. And so that starts with, measurement system assessments such as gauge
Right.
R&R techniques. And I regularly come across measurement systems that just have way too much error and that affect the ability to use that data to make effective decisions. But beyond that, I mean, one of the things in SPC to be very effective is to ensure that we've really identified those key process input variables to our process. And how do we do that? I mean, because we could have the best control charts in the world and maintaining and monitoring these processes, but if we're not monitoring the right things, again, we're not going to really get the benefits. So,
Good point.
how do we do that? Well, one tool we use for many things, including that, is design of experiments. Probably of all the tools that we use in our consulting practice, is probably the most common and useful. But DOE is, if you're not familiar with it, is just an extremely efficient experimental approach to understand cause and effect relationships and developing predictive models. And the idea is, once we collect some data in a very kind of structured, useful format, we can develop these predictive models for not just one response, but many responses, right? Because our products have to do more than one thing usually. They have to meet many performance requirements. They have to be reliable, and they have to be manufacturable, and so on and so forth. So through the use of DOE, we avoid the over-reliance I see today on trial and error approaches that are not just inefficient,
Right.
but they're sort of inadequate because, one thing that I see in almost every industrial system are the fact that the factors, the inputs to a process, whether it's a product that affect performance or affect outcomes, just how we test a product, just affect the outcomes that our customers are expecting. Those factors tend to be involved in interactions, meaning that the effect of one factor on the response, say temperature, depends on where other factors are sent, or depends on other design parameters. So to think that we could sort of vary one thing at a time and use that approach to uncover and model these interactions is not true. And so DOE is just an invaluable tool for understanding those interactions, understanding the main effects, developing these models, and it also allows us to kind of avoid the trap of just seeing correlations and think that that's somehow a cause and effect relationship. I mean,
yeah, right.
The whole point of these models is to predict, okay, if I want to hit some target result or maximize my result, what should I do to my product or my process parameters? And by observing just data in a haphazard fashion, we could see correlations, but only like in a controlled experiment where we're balanced and we're running combinations where everything is run with everything else, do we enable that cause and effect type of relationship to be found. So DOE is a really useful tool for to support quality and reliability. I mentioned reliability just now, but that is another important set of tools, right? So,
Sure.
you know, failures that occur over time, have to do with the reliability of our product, and certainly things like adequate reliability testing. And I'm talking about not testing 3 units and hoping nothing fails, but I'm talking about testing a sufficient sample from a production environment and actually estimating testing until failure, perhaps in an accelerated life test if we need to shorten the testing time, but to actually estimate reliability. So we know how reliable the product is, not just passing some sort of arbitrary test. So I think those are some important tools that anybody can use with a little bit of training and then some support with some experts.
Steve, I'd like to ask you one more question. I don't know if you have any suggestions about how quality and reliability professionals can help create a culture of quality in the organization. How can they help champion quality with their coworkers and colleagues and suppliers?
Yeah. So, I guess I have a couple thoughts. I think every quality and reliability professional, myself included, we can all maybe do a better job of kind of showing our value to facing organizations and certainly to management, and that's only going to help us promote what we do. I think it's. I guess I get a little sad sometimes when I think back in the 70s and 80s. I wasn't doing quality back then, but my perception is that there was maybe a more value placed on maybe industrial statisticians or people who were doing modeling and ensuring we have process control in our facilities. And I think some of that's gone by the wayside. And I think some of the talent that's coming out of universities is going into pharmaceuticals or Wall Street and doing financial modeling and quant stuff. And I think we can do a better job of showing management, through the use of some of the tools I talked about, just how useful they are to the success of the organization. And I don't mean just upward. I think we can also do a better job of, getting the people that work in our plants kind of more involved. And just take SPC, for example. I've been in places where, this tool, it's almost like the operators think that it's a tool to check up on whether they're doing their jobs rather than a tool to enable them to own their process and to have a tool that allows them to understand what their process is doing and that they're allowed to stop it and help understand, why the process is going out of control. Because those people who live with that process, they're instrumental to ensuring that we detect and find corrective actions for these special causes.
Absolutely.
Yeah. And then sometimes I'm just amazed. Unfortunately, our firm is in a place where we don't necessarily have to or do a lot of marketing, but occasionally we'll be in a meeting with a pretty high level person, maybe a vice president of product development or manufacturing, or in a smaller company, maybe even a CEO. And we always love to just take out like a DOE case study. And I'm sort of always surprised that they look at this and their jaws drop half the time. And they're like, how do we get this? Like, this is not some new technology that's just rocket science. It's basically blocking and tackling of understanding a process, right? And so the fact that so many of these heads of quality, to me, they don't seem like they even know about some of these more quantitative tools. It's a little surprising to me. And I think the last thing I'd say is that now might be an easier time because I think senior management's being bombarded with things like machine learning and AI and big data, and there's more buzzwords around about how all this data and machine stuff can make their companies more profitable. And I think that why can't us as quality and reliability professionals just sort of latch onto that and say, yeah, we've been doing this for a long time, and here's how we're going to do that with understanding our production processes better by doing some upfront process understanding work, modeling, knowing what we're going to control, and really just kind of leveraging what's going on around industry in general to really help improve the culture and the emphasis on this idea of problem prevention through process control.
Yeah, maybe we need to call it blockchain, Steve.
Yeah, exactly. Well, that would certainly help our stock price if we did, but yeah.
Steve, this has been great. Thanks so much for joining us today.
Oh, it's been my pleasure, Tim. Enjoyed it.
That was Steven Wachs, principal statistician at Integral Concepts Incorporated. In April 2018, Steven Wachs's online course on SPC and process capability will be launched on the Ascendo Reliability website. This is Tim Rogers. Thanks very much for joining us.